Welcome to today's class. I'll be going through I'll start going through strings and then we'll go through pointers and then arrays and then record structures. Hopefully we can also get to functions. So let's get started. So I'm gonna open Notepad and then I'm gonna create a new tab and then I'm gonna start writing the notes, right? So I hope we're on the same page. I hope everyone's on the same page. If I'm not mistaken, we are. Remember when we talked about signed, unsigned data types, right? And we said signed, it's when it can accommodate both negative and positive values. And positive values. And then when it's unsigned, it can accommodate only positive values. Only positive values. That's where we ended, right? We're talking about data types, how to declare variables and all of those things. So now I'm going to continue because I forgot to talk about the strings, right? Strings and characters. For those whom have had a session on that, it's fine. This will just serve as revision because I want us to move on, like to be on the same pace, to move at the same pace. So when it comes to strings, right? Remember we said computers, they use binary, right? They use binary numbers to represent anything, right? When I say anything, it's literally anything in a computer. That's how the computer represents information. So since it uses numbers, basically binary numbers, 0 and 1, that's what it uses, right? So since it can use this pair of now these two numbers, right? These two binary numbers, right? Bi meaning two. So this means that it is going to use a set of zeros and ones in order to to give meaning to anything. So since we have we have that understanding of okay, someone just joined. Oh, hey Kira,
Oh,
you good?
yeah, I'm good. How are you?
I'm great, man. So I already just started just in case you guys didn't show up because yesterday you guys couldn't manage to show up. So I was like, it's cool. I'll just make the video anyways because I'm sure you're occupied with other modules.
Yeah, but I think I did say that Tuesday is church, so that's why I couldn't make it yesterday.
Oh, oh yeah, yeah, yeah. My bad. Yeah, remember Tuesday yesterday it was just for me to explain the practical.
Yeah,
So that was pretty much that. Yeah. So it's not like we're going to have sessions on Tuesday. It's only gonna be the times that I think I said Wednesday, Thursday, and Friday and Saturday, I mean. And then if there's a need, we can also have on Sundays. But then since it's gonna be recess next week, I'm thinking of proposing this. We have at least two sessions a day, one in the morning and then one in the evening.
yeah,
If
that
we
would be
do that,
fine.
if we do that within that week, we would have covered like the whole semester. We might even
Yeah,
cover, we might even cover like at more, like go beyond like what what you currently have covered, which is going to be beneficial, especially for the practicals after recess.
yeah,
Okay, so I'll just propose that. I'll just write that in the group so that everybody knows.
yeah.
But
Okay.
then
No,
if
that's
they're
fine.
watching the, okay, no problem. So I was just recapping. I was talking about signed and unsigned, what we went through, and that a computer represents everything, every data, every piece of data in terms of zeros and ones. So with that understanding in mind, how can we represent characters? Let's start with characters, right? How can we represent characters or just letters Some people are more familiar with the term letters of the alphabet. So how can we represent letters of the alphabet or characters in a computer? It's the same thing. We use a standard code ASCII. I forgot what it stands in for, but then I know it's a American standard for something information interchange. I forgot what the C stands for. So it uses what we call an ASCII table or an ASCII approach, but then I'll just call it ASCII table because that's what it's called. So by ASCII table just means that each letter or character is assigned, each letter or character is assigned a numerical value, which is going to be an integer. So that's what the ASCII table is all about. Since everything in a computer uses binary zeros and ones, so obviously we need to use the zeros and ones to represent characters. So if I go here, right, ASCII table, you'll see that there's the ASCII table. It shows you each character, whether that's a space or that's a exclamation mark or it's double quotes or it's a hash symbol. Each and every single character, it has a numerical value or an integer representation. So since each there's a term for that, right? When you assign a numerical value to each letter or character, right? We call that process is called encoding. That's what it means. But then if you do it vice versa, so you're changing from the letter to the number, that's called decoding. So we are decoding. Encoding is giving that number, basically assigning each letter with a number, we call that encoding, which is basically converting from the numerical value to, no, I think I'm doing it right. I think I'm mixing these two things. If it's from the number to the letter, no, that's decoding. Yeah. If it's a number to the letter, that's decoding. And then if it's from the letter to the number, that's encoding. So it's actually vice versa. But yeah, you don't need to know these two terms. I was just explaining it for computer science 2. You'll get to computer science 2A, they'll tell you'll still do the same thing. Characters and strings, they're still there. Still the same thing. So I was just explaining that so that you get an understanding. So with this understanding, now I can really understand how characters work under the hood. And to declare a character, right? To say you want to remember, to declare is to say that I want to make the box available. That box where I'll be storing all the information that I need for my application. That's what I'm doing by saying I'm declaring. I'm just making that box available for use. So to declare character, a character, we use um, the keyword char. So when C++ sees the keyword char, it means that this is going to be a character. As you can see, the char was derived from the word character. They just deleted starting from A going to R. It was just sort of like a clever way to come up with, and they try to make sure things that they are short and easy to remember. So they just said, let's call it char. So you can say char, and then I can just say it's letter, semicolon. Remember, the semicolon is like a full stop in English. It's very important. Since we usually let things slide, like when you're talking over the phone, like via WhatsApp or Telegram, we don't necessarily take punctuation seriously, but then a computer does take everything serious, including punctuation marks. So your semicolons are very important. And then to initialize or to assign, right? To assign a value There's two ways. Remember, we have an understanding of how characters are stored under the hood. Each character has a numerical value. So that means I could initialize, basically a char is sort of like an advanced integer, right? It's an integer that can be used to interpret letters or characters. Hence it's called char. It's still an integer. To show you that it's an integer, you can set it to any number. There's two ways to initialize. You can say it's equals to 35, and then if you check 35, it's going to be equal to hash, right? So while I feel like it's best to sort of like show the code, because if I just speak, you can't really trust what I'm saying. It's hard to like really picture what I'm saying, but then this is how it actually works. This is the first way. And then the second way is to say letter. You initialize it to the actual character. We use the second approach because obviously that's easy for human beings like me and you to understand. Instead of, remember, we're bad with numbers. We are very
Yeah.
bad with numbers. So to initialize it using the proper way, you can use single quotes. And then you pass that character. And remember, it's called single quotes because it accepts only a single character or a single thing. So I can initialize it to hash like this. So these two lines of code, it's exactly the same thing.
Mm-hmm.
So I'm gonna create a project and call it tutorial 01, and then view manager sources main.cpp. So let's do that. Do this. So let's initialize that character, right? So char letter as usual. And remember, you can combine the two lines. You can declare it separate like this, right? You can declare separate like this, and then assign in the next line is equals to 35. And then you can assign in the next line. In the next line, you can do it separately, or you can do it in the same line, essentially killing two birds with one stone. So this will be equal to 35 like this. So when it has like when it has both, we call that declaring and assigning. So you're declaring and assigning at the same time, simultaneously. So I'm just gonna use the first approach. It makes my life easier. I'm gonna have one less line of code. Then I'm gonna output that letter, C out letter like this, and then output en line, right? And then I'm gonna run it, and then as you can see, there's the hash.
Is
Yeah, it is there. So it is indeed true what I'm talking about. As you can see, I was looking at the ASCII table. This is what I expected, and that was indeed the output.
mm-hmm.
Basically, a char is an advanced integer. It advanced integer in the sense that it knows that this integer should be interpreted as letters or special symbols. It's still an integer under the hood. That's why I'm able to initialize it to an integer, because it views the integer, it treats the integer in a special way. Or the second approach is I can literally put the hash symbol in there like that, and then it's still gonna display the hash symbol on my screen.
Yeah.
So that would be a character. And then that's pretty much what a character is. That's all you needed to know. And then we can go to strings, right? But then that's the thing. Before we go to strings, you'd have to understand um, pointers, right? So, what is a pointer? So let's just start there. So I'm just gonna comment this out. A pointer is basically an address. It's an ability for us to store two things, essentially two things. Because if you remember the diagram, let me find the diagram. I think it's on downloads. Uh, okay, I think this is the one. So let me open this and then open that chart. I think I still have it. I always save my things. So open existing diagram, open this one. Okay, perfect. I still I still do have it. So remember with variables, right? We have these things called it is everything is stored when you create a variable, it's like you're saying make a box available enough for me to store that specific thing based on the data type. So in my case, I'm gonna create a value. I'm gonna call it value, right? So when I do this, I'm just basically saying create a box, and then the variable name will be the label of that box, and then int would describe what type of things should go inside the box. That's pretty much all we're doing with the variable. And this box will be stored in a specific drawer. And in that specific drawer, it's going to have an address, just like we as human beings, we have an address of where we reside or where we stay. For example, you stay at rest. That rest that you're staying in has an address. You stay at home. That home that you're staying in is an address. You're staying in an apartment. That apartment has an address. Every everything has an address. So it took the programmers borrowed from that concept. They're like, okay, since everything that resides somewhere, it has to have an address. Even if it's like a pencil, we can, or let's just say water, right? It resides somewhere, even though you might not necessarily you can't necessarily say it's an address, but then it resides somewhere. How would I find water? If, let's say you ask one of your siblings, where's the water? And then they tell you it's in the fridge. That's a location right there. Yeah, they're telling you where to find it, and it's currently residing at that place. So technically, you could say that fridge can act as like an address where that thing resides. So as you can see, everything at the end of the day has an address. So they took from that concept. So that means every variable we create has an address. You might ask yourself, if it has an address, how do we get the address? So looking at this example, I initialized it to 0. I could just initialize it to 120. That's still fine. So let me just say that I initialize it to 120, right? So I'm going to say is equals to 120. And then I'm going to see out the value. So now how do we output the address for a variable for that box? Basically, how do we find out where that box resides? You find out by doing this, by using the address of operator. Address of operator. Basically, this means get the address of that thing on the right-hand side. Anything that's sitting on the right-hand side of this ampersand. Another term for it is called an ampersand, but then it's called in C++ terms or programming terms, it's called an address of operator. By address of, it means, in a way, you could say that when you see something like this, let's say address ampersand value, this can translate to address of value. That's basically what it means when you see this something like this. You start by putting the ampersand followed by the variable name, and then you should output the address. So the way it goes about doing this, you don't have to worry about that. But then all it does is like, okay, when it sees this, it's like you're giving it an instruction. Remember, the computer's main purpose is to follow our instructions. It should do everything that we're commanding it to do. It's like a pet. You're telling it to bark, it should bark. You're telling it to sit, it should sit. So that's pretty much what a computer does, right? So when it sees this, it's like, oh, you want me to go find the address of a box with that label. That's why if you try to do this, right, let me show you a problem. If you try to say, for example, I create a short and I call it the same, I declare the same way as the previous one, that's when it's gonna complain. You'll understand why it's complaining because there's techniques like this to find addresses of the box based on its label. So if you have the same labels, it's gonna get confused. Like which one do you which box are you talking about? Because there's two boxes. There's a box that stores an int, then there's a box that stores a short. So which one is which? I get confused. So that's why it's not allowed to declare variables that exactly the same way. That's one of the reasons. Okay, I was downloading something here. Let me close that. So that's why it's not allowed. So when it says this, like, oh, go get the address of that thing on the right-hand side, which is that box with that label. Another way to do it, I found it recently. There's a function called address of, which takes in a variable, and then it returns the address of that variable that it takes in. I just found out about it recently, which is a cool thing to showcase maybe when you're doing your practicals, so that you just shock those assistants to show them, okay, I know my stuff. So I can output the address by saying see out. Remember how we output the address? You're going to start with an ampersand followed by the label on the box or that variable that you want to get the address of. And then it's going to output the address. So now we're going to see the address. And remember the addresses, they start, it always has this prefix 0x. That 0x just means it's in hexadecimal format. Hexadecimal format, remember we use the decimal number system, which basically numbers from 0 to through 9. The hexadecimal, there's the keyword decimal in that name, right? Decimal just means that it's 16 values or 16 numbers that are used to represent any number. And there's a keyword decimal there. That means it has some, there's a part of it includes the decimal numbers, which is 0 through 9. And so basically it counts from 0 to 9. To count to say 10, it starts using letters. So after 9, it's gonna say A, and then B, and then C, and then D, and then E, and then F. So if you count these numbers in total, there should be 16 numbers. Remember, we use decimal number system, which means we make use of 10 numbers. So
Yeah.
0 through 9, that's already 10 numbers. 11, 12, 13, 14, 15, 16. As you can see, that's hexadecimal. It does that because with binary, right? Remember, binary numbers can be very long. Imagine you have this address. It's way too long. It's way too hard to remember, even for the computer. The computer won't really necessarily have a problem, but then sometimes it's the programmers we also want to see the addresses and make use of the addresses. How will we understand this if it's this long? So that's why they chose the hexadecimal format to represent the numbers inside things like addresses, because all of the remember hexadecimal makes use of these numbers. So that means this can be abbreviated. This can be abbreviated into something small. Remember, it always has the prefix 0x to denote that it is a hexadecimal number. And then after
Mm-hmm.
the x follows the actual hexadecimal number. It can be 1EF123. This is way better compared to this. So that's why it uses the hexadecimal to represent addresses. So this is the first way to get the address. And I also told you the second approach is to use the function address of, and then you pass the variable in there. It's going to return the address of that variable or of that box where it currently resides. So the addresses should be the same. As you
Yeah.
can see, is the exact same value. So just there's many ways to kill a cat. You can choose the first approach, that's up to you, or the second approach. So as you can see, we have limitations with the variable. It can only store the actual value at a time, the value, not the address. To get the address, we have to use or make use of other means. As you can see, I use the ampersand there, and then this second approach, I use the function. So you see that it becomes very cumbersome. It's like a very untidy thing to do. So
Yeah.
with pointers, what they do is that you actually have full access. You're in charge. You have access to the box, which is the value, and the address. So you have access to two things at a time. So you don't have to use things like functions or ampersand, the address of operator. You don't have to use any of those things. So the second one is pointers, right? So the pointers, I'm gonna do it like this, int value, and then semicolon, right? To create a pointer, you put a star. It's up to you. You can put the star next to the int to the data type, or you can put the star next to the variable. That's up to you.
Yeah.
It's just a matter of preference. So with pointers, right, they work with addresses. Remember, they store an address. So with pointers, when you declare a pointer like this, right? So let me show you an example. So I'm gonna have to write some notes inside this code. So an example how to declare a pointer, right? Declare a pointer. You're gonna say the data type, and the start by the variable name and then semicolon. That's how you declare the the
Pointer.
pointer, right? After declaring the pointer, when you call, so when you call or when you use, let me just phrase this way, when you use the variable name on its own, you are actually using the address. You are actually referring to the address, actually referring to the, so let me put it in the next line. You're actually referring to the address. So basically, if you use the name of the variable without that pointer or that without that star or that asterisk, without it, it's actually referring to the address. By address is what do I mean? It means this. It's going to be in hexadecimal format. To get the value, right? It's the same thing as when you visit your friend. Let's say or if you visit someone, you don't necessarily say your friend, but then at the end of the day, it's the same thing. Let's say you meet someone, right? You made a friend at school, and you just made that friend that day, right? And then you exchanged contacts, right? And then you need to go to that person's place so that you can work on the group project. And then obviously that person needs to give you their address. Send me your location, just like Kelly once said. So that person needs to send you your location, you get that address, then you go to that address to find that thing, right? Or that person. The same thing, like I said, things like computer science was made available by people like you and me. So they live in the real world that we live in. So they borrowed concept from that.
Mm-hmm.
So when you use in conjunction, right? When used in conjunction, so let me do this. When used, by used, I mean the variable. When the variable used in conjunction with the asterisk, you actually going to that address. You are going to that address to get the value or what is inside the box. It's like you're visiting your friend. You're going to your friend's address. Obviously, if you go to your friend's address or to that address or go to that address that your friend gave you, won't you find, well, don't you expect to find your friend there?
Yeah.
Exactly. You expect to find that person there, right? Because that's where they reside. They're at that address. So in order to initialize the pointer, right? Remember what I said. If you use the variable name without the star, you are referring to the address. So remember, it's a pointer. It needs to be initialized by giving it an initial address. So I'm gonna create some variable and say it's equals to 10. And then to initialize it, right? Remember what I said, it needs to take in an address. It's called a pointer because it stores an address. Technically it stores both, but then its main goal is to store an address so that you remember when you remember this is the part where I'm still declaring it. I'm declaring it and at the same time I'm assigning it an address. So I need to assign it an address. So remember that's why I was talking about the address of. So I need to use the ampersand there to say, okay, this pointer should store the address of num. So now it's like technically this variable called value. It's like technically it has moved in the place where this person stays because we are now in the same address. That means we're in the same place. That means, which makes perfect sense what I'm about to explain right now. That means if I was to try this, right, to say, remember when used in conjunction, when you use the pointer or that asterisk in conjunction with the variable, it means that that pointer, right, it means that point to this address stored inside that variable. Or it means, in other words, you can say it means go to this address. Which address? This. Remember, we've used it without the star, that variable on its own, it stores the address. So that's what it means when used in conjunction. It means point to that address or go to that address. To show you that it stores an address, before I try to change the value, let me just output value. Remember, it's now a pointer. Value without the asterisk is going to output an address. So I'm going to build and run. I should expect a hexadecimal value. As expected, there's the hexadecimal value. Because the pointer, if you use the pointer without the asterisk, or you just treat it like a normal variable, that would represent the address. To get what is inside the that address, right, at that location, I point to that address, or I go to that address. So obviously now I'm gonna see 10 as my output. As you can see, there's 10 as my output because I currently reside in the same place where num resides. That's basically pointers. It's a way of us to work with addresses. Or you could do this, right? You could initialize your pointer in the next line. You could say, remember when you use without the asterisk, it's referring to the address. So I could set the address and say, set the address to be equal to the address of num. There's two ways you can go about doing it. I can initialize it using the second approach. It should work perfectly fine. As you can see, it's outputting 10 because that means that the address was initialized correctly. Like I said, without the asterisk, it refers to the address. So here in this line, I'm changing the address. So that's why I'm even using the address of operator to get the address of num, because this variable without the asterisk, it refers to the address. So therefore it expects an address. So since we reside at the same place, right? That means if I change, the changes that I make will also affect the other individual. Imagine you moved into your friend's place. That means if you drank their whole, if they bought, maybe they bought, let's say maybe they bought cranberry juice, right? And then it's in the fridge, and they bought like the fanciest cranberry juice. You've never seen it before, and you're a huge fan of cranberry juice. If you drank his cranberry juice, that means he'll also be affected. That means you also not have that cranberry juice because at this point in time, since you have moved in, you it's like you reside at the same address. That means you're technically like roommates in a way. That means whatever I eat, if I don't leave behind for my roommate, that means he will be affected. He won't have anything to eat. So that means this variable, this pointer over here, if I make changes to that value, it will affect num without me even touching num. So let me show you. So I want to change the value, right? That means I'll take the address, this address, meaning the variable name without the asterisk, and then I'm going to point because I want to go inside the box. Point, go to that address. I'll find that box, and then within the box, I want to set it to be, let's say 95, right? I set it to 95. You'll see that if I output the value of num, or I just output num, right? Something weird happens because num was initialized to 10, but then how come it's now outputting 95 and not 10? Because like I said, this pointer, it now points to the same address or the same location where this one resides. That means if I make changes here, it will affect my roommate. So if this person drinks that cranberry juice, drinks the cranberry juice, then it also affects my roommate, the person who bought the cranberry juice. They'll be like, ah man, you finished my cranberry juice. You see, that person got affected because you currently reside in the same address. Hence, here in this line of code, that's where I initialized it. So now you reside at the same address. And then remember, there's two ways of initializing that, getting an address of something. You can call the function. You see that it's going to work exactly the same way. That's what I was saying. You could use the function as sort of like an advanced way to showcase your skills in the practicals. So you see, 95, same output. Just two different ways of solving the problem. So that's pretty much pointers, right? It's when we want to make use of, as you can see, we can make use of both, meaning the address and the value. To get the value, I just point to. That means this variable technically stores both. It stores, this variable stores both the address and the value. And the value. Basically, the address, meaning the location, and the person who resides at that address. So it's those two things at a time. With this variable, we're only able to retrieve the person who stays at that address, but we didn't know the address. To find the address, we had to ask someone to find the address for us. With pointers, we can keep track of both of them simultaneously. So that's pretty much pointers, right? So with pointers, that's pretty much you have to know about pointers, and whatever changes you make, that address you are linked to or that address you are sharing, it will also affect that person who's at that address. And it's the same address. You can also double check by outputting value without that asterisk because we want to see the address. And also saying get the address of num. Remember, num is not a pointer, it's a normal variable. So I have to use the ampersand to say get the address of num. So I expect to see the same value because they currently reside at the same address, which is true. As you can see, they're identical. So that means whatever changes one of them makes is going to affect the other person. So that's pretty much what you need to know about pointers. So since we have an understanding of pointers, I was still on characters, right? So characters basically it's any character you see with the ASCII table, right? The ASCII actually makes use of only the characters on your keyboard. That's pretty much what it covers. To get things like emojis, we use something called Unicode. It's still assigning each character a number, but then that's a more advanced thing. An emoji is a more advanced thing because there's colors involved. It's like now you're referring to things like ppm, image, RGB, so it's a bit advanced. So we'll just make use of ASCII characters, keeping it simple, because that's what C++ only works with. The C++ that you're being taught, right? They might be C++ that works with the emojis, but then the one that you're being taught, since you're being taught the fundamentals, we're only working with the characters on your keyboard. Nothing more, nothing less. So we've covered pointers, right? So how do you declare what is a string? So a string is basically, remember, if a char is one letter, right? If a char is one character or represents one character, how can we represent multiple characters? Can we represent multiple characters? So we can represent multiple characters via a string. There's a string data type. So a string, right? The way I would like you to picture it, you can think of it as of a string of letters, bracelet. If you remember those bracelet that they sell, those people that they saw, whether you're at the mall, it's usually at the mall. They sell these bracelets where they come with letters, right? And then you can choose letters to form your name. And they're
Okay.
making use of that string, right?
Yeah.
Or wool or whatever. Just gonna view it as a string. So as you can see, if I combine each of the individual characters, they form a word. And then I can combine even more characters to form a sentence. I can even combine more characters to form a paragraph. And then I can eventually write a book. So as you can see, at the end of the day, when you want to represent multiple characters or words, it's basically a string of characters or letters. As you can
Yeah.
see, Niter is just a combination of KNITTER. It's a combination of all those individual letters. So it's like a string of these characters. Hence, they came up with the data type string. So this will be string. So to declare, same way you declare a a normal data type, right? It's going to be string and then followed by the name, right? I'm gonna say str name, something like this, right? And then to initialize a string, you have to put that string or those sequence of characters within double quotes, right? You need to use the double quotation marks. So I'm gonna comment out this and then go to strings. Okay, I could just leave it. I could technically just leave it like that. Yeah, I'll just leave it like that. So let's go to strings. Strings. So a string, to declare string. So a string is actually an object. What do I mean by object? You're actually referring to a class. So a string is actually a class. So you have to, it's not a normal type. So therefore you have to include its own header file before using it. So you have to say string, hash include string. That's all you have to do in order for it to be available. And then it's also part of the standard namespace. Don't forget to say using namespace standard. And then I'm going to say str name. And then the name is just, I'm just going to put Kiyotaka Ayana Koji. So that's how you would initialize the string, right? That's pretty much all you have to know about strings. And then you can see out to output the string the same way you're outputting characters. Remember, a string represents multiple characters, so you can use numbers to the same way you use numbers on a chart on a character or the chart data type. You can't do that because, as you can see, it's multiple characters. So you can't do that here. You you honestly can't do that here. You can only do it with the char because with the char, it's actually representing that one individual character. So we can refer to the ASCII table to see the numerical value for each character or that special letter that we want to output, then initialize that char variable to that number, and then it's going to output that character for us. So this is how a string would be created. So now you ask yourself, why did I start on pointers before talking about a string data type? I did that because string data type under the hood is actually like this. So string is equivalent to const char pointer. So I can just change this and say const char pointer. Because remember with the pointer, right, you can point to one value or you can point to multiple values or an array. Remember when you're doing images, your PPM images, you had an array, you had a pointer array, right? To dynamically allocate memory, meaning that you had multiple values. So the same applies. A string is basically an array of characters, which is true because it's just this is the first character, second character, third, fourth, fifth, and so forth. It's true. It's the same thing. And with that being said, since it's true, I'll show you a trick. So let me output this. You see, it works exactly the same way because under the hood, that's how string is. It's just that if you declare it as a const char, right, there's something that you need to take into account. You need to put is this thing called the null pointer or the null at the end. Because if you use const char was how you declare the string inside what is this? Inside C, which is the sort of like the godfather of C++, right? So you'd declare it like that. There wasn't like string. There was no one who created the string class. So you'd actually have to do it like that. And then the way you'd worked, right, is that you'd have your characters and then put that null at the end. This null is just basically saying 0 so that it knows when to stop. It's going to start at K, keep going, keep going, keep going. And then the moment it sees these two special symbols, it knows, oh, I've reached the end. So therefore, I stop there, excluding that null pointer, that \0, excluding that null pointer. So strings like that, they're actually called null terminated strings, basically meaning that it's terminated by a null or a \0. That's what it means. Even though it was working that without the \n, if I was to go through all the individual characters, it was going to be a problem. And since I said it's an array, that means I can get at that specific index a character. So to show you that this works, I'm gonna get an index. Let's get the letter K. Remember, arrays are 0 index. They start counting from 0. So I need to put 0 here if I want to get K. And then if I want to get the next one, I increment by one or increase by one. So this will be index one or position one, position two, position always position three, and so forth. So I'm gonna build and run, and then there it is. There's K. Like I said, a, a string is basically an array of characters, which is true. Because if you look at the bracelets, it's just a collection or an array of characters. At the end of the day, all of these are just characters that are a collection, right? To form that one word or that sentence. So that's pretty much strings. That's why I needed the pointer there to explain the pointer before we got to that.
Mhm.
And for those who like experimenting, who like advanced things, if you use a string, remember always use the string. I'll just show you in the const chart to show you that it actually works. But then just know string under the hood is just implemented as const char pointer. So which is basically an array of characters and const that const means that those values cannot be changed. What does that mean? That means you cannot say str name, right? At index 0, I want to set that to remember when I index, I'm actually referring to the actual character. So therefore I'm gonna use single quotes. So let's say I wanted to set this to A. It should complain. The C++ is very moody. It might not complain. That's problem. You see, it didn't complain. It should complain. So let me just choose, let me try to use the const char point and see if that would actually make it complain. Yeah. So it's preferable to use the const char. As you can see, it says read only. That means that const there, it's preventing you from reassigning or changing the characters. So
Mhm.
that's pretty much strings. Strings, they're annoying on that one part is that they cannot be changed. And then there's that. So with this with the string data type, seems like it does allow. Let's try to run. The first letter should be A. Okay, yeah, it did change. So strings, with we've used the string, the string, it actually has the capability of changing, which is not a good thing. It's not really a good thing. It's not common throughout the programming languages. This is only possible in C++. Oh, you can. It's allowing you to change the individual characters. Okay, so that means it might only allow you to change the, but then there's still the same thing. It shouldn't even be allowing me to change that. But then it's fine. So there's two ways, right? We can work with this with the string, especially with the string, not when you use a const char. When you use a const char, you have to use the square brackets. When you use the string data type from that header file, you can use this method called at and then you specify the index. It means that go into my string and then get me a character at that position, meaning that I'm going to get out k because k is at position 0. Okay, not k, a, because I've reassigned it to a different letter. So that's pretty much that's an advanced way of looking at it. Just that you might ask yourself, why is there the at position? So the at position, the at function, remember this is like I told you, it's a class. So when you have this is actually an object. It's not a data type. Remember on data types like integers or chars, you can't call methods on that. But then miraculously on a string, you can call that. You can call them. Why? Because I had to include a whole header file since the string is a class. It's not like a normal type. It's an object. So when I see this, it's actually an object. And then I can say dot add. The add method, right? The only difference between the add and the square brackets is that the add method, it validates the value you're passing, the index. If it doesn't exist, it'll shout at you. This one it doesn't double, it doesn't have error handling to check that, the index, to check whether the number you've entered is in the right range. It won't check. So to show you that, I can put 100 there. And then it should give me a clear error. I don't know. Sometimes it won't give you a clear error. Yeah. But to some extent, I get it. You see, S standard out of range. And it told you that you passed in 100, which is 100. But the maximum, the last index or the last position is position 18. So you went beyond the size. You see, there's the size, which is actually 18. So there's 18 characters and you went beyond. So let me try doing this with with the square brackets, and you see that it'll it might not might I don't think it will, but then let's see. Yeah. You see that it ran. It showed zero that it was successful, which is wrong. That's wrong. It can't return zero. Nothing was successful here. The position didn't exist, doesn't exist. So you see why there's a benefit of using the at function.
Mhm.
Yeah, so I advise you to use the at function. That's why they created it for you. Remember this string data type or the string class, this object that you have, the string object, it has methods that you can call on it. I just forgot the other ones. But then there's multiple methods. You can say dot. Okay, now it's not showing me. It usually shows you the methods that are available. I guess I must switch to Visual Studio because code blocks is just it's always tweaking. So that's why the add method more is better. So I'm just gonna put it here so that you can remember it. So that's pretty much strings, right? And you could get the length of a string. I think you can use size. Is it size? Yeah. I think you can use the size function. So str, basically you get how many characters or how many letters are in the string. Okay, I forgot to remove the null. If you're using the string data type, it automatically appends or adds that null for you. That's why they created a whole class for you because they saw that a lot of programmers forgot to put the null pointer there, which made your program unsafe. So if you're using a string data type, just don't put it. If you want to use the raw C approach, raw string C strings, you'd have to put the null pointer of yourself there. So I think I can call the size function to get how many characters are there, right? I think I can do that. I think we saw that it should be 18, right? Yeah. So
Yeah.
it's 18. So it shows you how many characters. Remember, even the space is applicable to that number. Why the space? Because if you look at the ASCII table, the space also has its own numerical value. That means it exists. It knows the computer knows that space exists. So that's allowed. It's going to also count that space. So that's pretty much strings. And then with strings, we have an understanding of strings. Now I think we can go to arrays, right? We can go to arrays. So now let's just go to arrays. So with arrays, right? So I didn't explain something important here. So you might see this thing in your slides or in the notes. They'll talk about it a lot. There's this thing called a stack and a heap. I'm sure you've heard about that. So with the stack and heap, right? It's like different locations, right? It's like or different technically it's different locations, but then it's also like different approaches of storing things, right?
Yeah.
But then they're still the same way. They're exactly identical. You have drawers and boxes exactly the same way. The only difference is it's a subtle difference. Remember with variables, right? Every time you create a variable, you allocate a memory. But then you ask yourself, well, I didn't see the keyword new here. So where did I allocate memory? Well, you're using the stack. The stack, it manages everything for you. So everything is in the stack by default. So when you're using the stack, that you are using a memory or a place whereby everything is managed for you. I sort of like make this silly example that the stack is like it's like at your grandparents' place, right? When you go visit your grandparents, they'll always be treating you like a child. They're like, no, no, sit down, don't do anything, just chill, relax, we'll do it for you. Especially grannies, they're like, no, don't worry, you don't have to cook. You're always cooking when your mother's always making you cook. Let me cook for you. So the stack is like that. It's like your granny's place. Everything is managed for you. You don't have to be responsible. You can just they'll tell you sit on the couch. Just chill, relax. Everything will be done for you. Do you have any
Mhm.
dirty clothes? Let us know. You can put it. Granny will tell you that I'll put them in the washing machine for you. And then you'll be like, no, Granny, I need to work because you're accustomed to that, right? Like doing
Yeah.
things for yourself. Then she'll be like, no, don't worry, you're at my place. Here are you're not you're my grandchild. You're not gonna be doing any work. So that's the stack. It's like your grandparents' place. And then the heap, it's like your parents' place. They'll be like, ah, chief, you wanna cook, you wanna eat, you're hungry, go cook for yourself. So that's how I view the heap. This is like your parents' place. You do everything. The allocating, the deallocating, you do everything. You are responsible. It's like here you are fully responsible for your actions. Everything that you do, it's your own responsibility. And then here, it's fine. They can let you chill on the couch. You can even play games the whole day. Grandparents are chilled. They'll be like, it's fine. You're always busy with your schoolwork and things like that. Just chill, relax, have fun. Life is too short. Grandparents are like that. So that's like the stack. That's where everything's managed for you. That's why we didn't see keywords like, remember every variable that you're using, there's going to be a new keyword and a delete keyword. New meaning to allocate, delete means to delete memory that was used.
Yeah.
So it's always the case. If you're using the stack, it's done for you. If you're using the heap, you are in charge. So new, when you see the keyword new, it means that you're allocating memory because you want to use that box, right? And then when you're deleting, when you use the delete keyword, you're deallocating the memory. That's pretty much that. It works exactly the same way. So with the heap, right? The one thing about the heap, you never actually know you never actually declare the variable. You don't have to worry about that. You just point to that address. So what happens is, right, this is what happens. So let me just copy this box. So let's just say this is the variable, right? I'm creating a variable here. That's the variable, and then that variable resides at a specific address, basically at a specific drawer with an address, right? And then what happens is if I create that box and to work with the heap, right? The only way to work with the heap is that you need to use pointers. That's why I started explaining pointers because we need to understand that. Pointer is just an address. So what happens when you allocate something on the heap? When you allocate something on the heap, it returns the address of which drawer has that box. So obvious, if it's returning an address, I need to store the address. How can we store an address in C++ through pointers? So how can we tell it we want to use the heap memory? We can tell that we want to use the heap memory by using the keyword new. So when it sees the keyword new and delete, heap memory is used. And you have to be in charge of managing everything. After eating, you have to go wash your own plates. You can't see, there's no granny anymore. You can't be like, hey, granny, there's the plates. Then she'll be like, ah, it's fine. Sit down. Don't worry, I'll wash them for you. Nah, this is the heap. You have to manage everything for yourself. Even cutting the cord, the connection, because there's gonna be something that we're gonna that I like to view as like the connection between the stack and the heap, right? Because if I create a variable, right? Let's create a variable. Let's allocate memory on the heap. So I can say I'll call it heap, right? And I need to make it a pointer. Why? Because remember what I said. When you use the keyword new, it's going to return an address of where that box resides in the heap. Basically, in which drawer does it reside in? So that's why I need to use pointers because pointers allow me to store an address. So I'm going to say allocate a new integer on the heap. And if you look at this, there's no brackets, right? There's no square brackets. That means it's one integer. And
Mm.
I didn't remember I'm using the heap. It's going to be a really random value. It's going to be a random value. So what happens when I do that? What happens is this. Let me show you how it looks in in terms of the stack and the heap. So it's like, oh, you want a box with this label heap, right? Come on. So the label is heap, that's the label. And then it's going to see, okay, so this label, it accepts addresses, right? Remember when you say pointers, they just store an address. So type of data is going to store an int pointer, a pointer to to an integer, right? Basically an address to an integer, int pointer. So now it's no longer what's going on. Oh, okay. So welcome, Koketso. You just have to
Like,
you just have to continue that first hour. You can have to watch the recording.
yeah, I'll do that.
Okay. So there's the box, right? That's remember every variable that you create, it's stored on the stack. But then some of the values like this integer, I use the keyword new. So that means the heap is now being used. As I've noted here in these notes, heap, when you use the keyword new and delete, the heap memory is used. So that means I must delete. I'm responsible here. If I allocate, I must delete. Basically, if I cook and I use the pots, who else is responsible for cleaning them? It's me, because I used the pots to cook, right? So I need to wash the pots and the plates. So don't forget to delete. And after deleting, don't forget to cut the cord. You'll see what I mean by cutting the cord. So this stores a pointer, or it stores an address. That means it points to somewhere else. That's what this variable is meant to do. So I said new int. It's going to say this new int keyword, these two keywords, and say, oh, so you want me to allocate a new integer or create a box big enough to store one int. Why one int? Because I didn't use square brackets. If I use square brackets, then I would say that's multiple integers. Like for example, if I say 10, that means I want 10 integers. So it's going to allocate exactly one integer. So let's assume this is the box, right? And I'm going to do this. And then this box is going, the only thing that is you can be able to keep track of is, I'll say the value. You can't keep track of, you don't have the name. It doesn't create a name for it. It doesn't create a label because you're accessing it via the address. It doesn't create a label for it. So it'll be some random value because I haven't initialized it, right? I
Yeah.
haven't initialized it. I'll show you a way of initializing it. I could initialize it even though it's a box in a different location. So what happens is when it sees this line of code, remember you always execute what's on the right hand side of the equal sign. So this right hand side means allocate enough memory or a box big enough to store one int. And remember, this box didn't specify what label we should have. We don't have to worry about that because we are keeping track of the address. Once it's done, this line of code that I've highlighted will return an address to that box that was created that's big enough to store an integer. Then that address, that's why I created a pointer because pointers store addresses. Since this line of code will return an address to where that box resides in the heap memory. So what's going to happen in essence is just this. It's just going to point to that address. And then basically what this means, I'm putting that arrow so that you understand what it means. But then in actual terms, this is what it means. It means that this value or this address will be stored inside that box. It will be right there. It will be stored inside the box. So this will be stored inside the box. That's what it means. But then I just drew that line so that you see that there's a link. I'm just pointing to that shelf with that address, whereby I created a box that's big enough to store one integer. But then remember, there's a mystery value because I'm not using the heap. I didn't say what default value should that box have. So at this point in time, it's just going to output a random value. So let's output that. So I'm just going to say heap value label like this so that I can Remember, there's multiple outputs here. I want to be able to tell what this is going to output. So I want to get the value. So remember, if you use it without the star or that asterisk, it's just referring to the address. I want to go to that address or point to the address. So I'm gonna dereference. That's called dereferencing or pointing or going to the address. It's just synonyms, just one and the same thing. Dereferencing, pointing to that address, going to the address is the same thing. They're referring to the same thing. So this one should output what's the value inside that box that I'm pointing to. Remember, this pointer stores that address, right? And one important thing before I run, one important thing, don't get confused. The actual box stores an address of another box, but that box itself has its own address. Don't confuse the two, right? That actual box itself has its own address. This is very important when it comes to when you look at your slides, because your slides, those foundational what slides, your slides there has something that looks a bit cryptic, right? It created such like a function, right? Let's say void hello, and then there was something like this. It had int pointer, let's say num like this, right? And then it took it by address. If you check your slides, there's something like this. So this is allowed, this is possible. Why? Because I'm pointing to, okay, not I shouldn't say pointing. I don't think it should point. Yeah, it should actually be like this. But then at the end of the day, it's still fine. But then this just means I want to pass it by address. That means I'm trying to get the address of that box that stores another address. What does that mean? It means this box here, it has its own address. I want to get that address, right? That's
Mm-hmm.
what it means. So just remember the box stores another address, but then that box that stores the other address, it has its own address too. Don't mind me using the same addresses. They're always going to be distinct and unique, right? Don't mind that. So let's see what random value stored in that box that's allocated on the heap. So it's a pretty big value. How much is this? 16,522,000. So you see, it's a random value. If you wanted to, you could, right? You could give that box its own default value. So by doing this thing called constructor initialization, right? I use a constructor to initialize that box. Like the way you've been using constructors, right? Still the same thing. You see, now it is a default value of 0. Why did I use that? I use that because C++ is like a very complex language. There's many ways to get to the answer. So with C++, let me explain how to initialize, right? Assignment. We're talking about assignment. How do you add values to your variable? There's multiple ways. If I have int x, right, I can initialize it like this is equals to 10. This is what is called C style initialization. Initialization, basically the way the C language used to it initializes its variables or the boxes, right? And then the second way is to use what we call a constructor. So I can say like declare like this, right? It means create an integer, name it y, or create that box big enough to store an integer. It's gonna have the label y, and it should take in the value 20. But then I'm using a different approach of initializing, which is called the constructor initialization here. Constructor initialization. And then the third and last approach, which is a safer approach because it gives you a clear error when you debug, right? These other ones won't tell you what the actual error is. It'll give you a weird error. This last one is like the most safest way to initialize your variables. Let's say I set this to 23. It's called the list initializer, right? List initialization, right? Basically, it's sort of like it borrowed that concept of initializing a list or an array. Remember, you can initialize the values of an array with curly braces. So it borrowed that to just initialize one thing now instead of those multiple values of the array. So this is the three ways you can initialize. So that's why I said I can do this here. Why am I doing that? Remember what I said on this, anything that you declare on the heap, it doesn't have a name. You see that this variable is no name, it's just int. There's
Yeah.
no int num, some int num, that's not, it's not allowed. It will crash. It won't even work. You shouldn't create something on the stack and give it a name, because at the end of the day, you have access to its address of where that box resides. So there's no need for you to be giving it a label. So these are three ways of initializing. I'll comment them out. Okay, I don't have to comment them out. Let me just leave them there. So this is how you can make use of heap memory. And then don't forget to delete. Remember this, there's one integer, right? I don't have to put in things like brackets to say, square brackets to say, okay, delete that whole collection. No, there's one value. All I have to say is delete heap. It means delete the memory that was allocated. So let me show you in terms of the diagram how that looks. This line of code, it means delete the memory. Remember when I used the constructor initialization, it set it to 0, right? So that means this box now it didn't have a random value, it now had 0 in it. And it was big enough to store an integer, right? I just didn't put it. Yeah, I must normalize putting everything. Remember the data type here, it was an integer. It's big enough to store an integer, and it should only accept integers, not strings, not chars, not booleans, not any of those. So therefore, what happens is that when it sees the delete keyword, it means delete the memory, right? This is you washing the plate after eating. You've used it, right? So clean up what's left to make sure
Mhm.
that it's clean and ready for use for the next person. So obviously what it does is just going to delete everything, even the value, everything delete. So it's like it goes back to being an empty box. Remember, there's always an empty box. When you create the variable, you're just giving that box a label and putting a description of what type of things should go inside the box. But then the boxes are always there. But then you see the box is we've deleted the memory, right? That means the box technically didn't exist at this point. It doesn't exist at this point in time, right? Since there's
Yeah.
nothing in the box. But then we still have the connection. You see, inside of our box for our pointer, we're still storing the address, meaning we're still pointing to that. So I need to use what I call a null pointer. Basically, I need to point to nothing. So null pointer, it's like \0, right? But then it is a keyword inside C++. You don't have to write it physically as null point. So I need to set the address of this box or whatever value inside the box to point to a nothing, basically nothing, so that it's easy for me if I don't do that, right, what's going to happen is I'm going to access memory that does not exist. I'm going to try to get a value from a box that is nothing, that's non-existent, because I deleted everything that's why that was inside the box. So it's basically an empty box. So I'm gonna mistakenly access that if I don't set it to null point. So I need to cut this cord, this connection here. So how do I do that? So I say my address. Remember, when you use heap without the pointer, without the asterisk, you are referring to the address. So the heap address, that address should now point to a null pointer address, meaning to nothing. So that if I try to dereference, by dereferencing meaning it means that I point or go to that address. If I try to go to that address, it will say we are going to an address that's now point that doesn't exist. So that I can understand my error and be like, oh, I'm trying to do something that's illegal. If you don't do that, it'll still have that address inside this box, right? Remember, once I set it to null pointer, this changes to null pointer. So this box is the value null pointer. Basically, it's pointing to nothing, to null pointer. So that if I try to point or dereference to go get that box, it'll be like, which box are you talking about, bruv? There's no box here. And then in that case, it's going to make it easier for me as the programmer because I'll get a clear error. So the error that you get when you try to dereference here, when you try to point to a pointer address, you will get or you get a segmentation fault error. You see it in your, if you use the terminal, that's why I don't like code blocks. Let me show you why I don't like code blocks. If I say C out, right, I'm trying to point to an address that does not exist. Remember, this is not allowed. Remember, everything is done sequentially. It'll get here, delete, and then set it to now, and then it's gonna go down. It's done doing it sequentially from top to bottom. And then it gets to this line. You're trying to point to that address, go to that address. But how? Because it's now pointer. How? So what happens with code blocks? It kind of jams. You see, it just jams. It doesn't tell you the error. That's why I say I don't like code blocks. How will you possibly understand that error? You can't.
Yeah.
So that's why I prefer Visual Studio. I think from now on I'll use Visual Studio. But it just know it's the same thing. It's just a different IDE. I just prefer that because it's going to make my work easier when I have to demonstrate errors. Because errors are something that that's common for all students, and you need to be able to handle those errors. So what I'm
Yeah.
just going to do, I'm just going to quickly show you here. I don't want you to say, this guy, it could be a scam. He just tells us stuff we don't see. He could be a false prophet. So let me not. I don't want to do that. So I want you to see that segmentation that I didn't lie.
Yeah.
Like one of those rappers say, no cap in my rap. I don't know who said that. I forgot, but then some artists say that. So ls just means list everything in the current folder. So there it is. I just want to compile, right? Remember, compiling is the translation. So I call G++, that's the name of my translator. It's like I'm saying use Google Translate. That would be the name of my translator. In this case, the translator that you always use for C++ is called G++. You'd have to download it, obviously. That's why I showed you how to install the terminal, because the main thing we want from the terminal is just that translator. So G++ followed by the file with that language you want to translate. And it needs to end in a .cpp because this G++, it only translates C++ language. It's not like Google Translate whereby it takes multiple languages. No, that's not how it works. It specializes in one language. So I want to compile the main.cpp file, and the translated version, or the machine language, the file with the machine language, right? It should be stored in. I want to give that file a name. How do I do that? You say -o, meaning the output or the object code, right? Or the object file. Object meaning the machine language. I want that to be given the name, that file with that machine language to be given the name main. And then press enter. And then it's translating now, right? And then I'm gonna press ls to list. You should see it now. It's called main.exe. .exe because I'm on the Windows platform. If you are on things like Linux or MacBook, totally different. So you see, this is actually how you see. It's not. It's a bit complex, right? Because there's a lot of things involved. But then at the end of the day, this translates to zeros and ones. So this is actually the language of the computer. You see how complex this is, and you see how short our program
Yeah.
is. Look at how many lines. Look, it's 995 lines of gibberish. How would you write something that in its own language? Very complex. That's why we use programming languages like C++, Java, and Python. So now I want to execute that file, right? I want to run it, right? So I'm going to say dot/. That's how you execute. Then .exe, followed by the executable, right? That .exe, it means executable. Executable meaning that you are able to execute it. Executable. Then I'm gonna press enter, and then as you can see, don't ever go around saying there's cap in my rep. There is segmentation fault. So this
Yeah.
is this is the benefits of doing that, setting to now point. As an advanced programmer, when I see this, I'm like, oh, I'm trying to dereference or point to an address that's pointing to null pointer. Then I go back and I'm like, oh, there it is. So let me comment that out. It's causing my code to crash. It potentially cause my code to crash in the future. So let me comment that out or just delete it. That's the main point of that, so that we know that this memory is no longer in existence. that box no longer exists when we see segmentation. So that if we try to do that in the future, we'll see an error called segmentation fault, which is just going to denote that we're trying to access a box that's no longer in existence. So this will just output segmentation fault, right? Seg fault error. So that's pretty much what pointers are all about, right? So this is pretty much the structure for pointers. And you can allocate multiple values, right? By just removing these round brackets and putting square brackets and the number of integers you want, or the number of that data type you're creating that you want. So we can go to arrays now since we understand the heap and the stack, right? We know that the stack is like our grandparents' place. Everything's managed for us by the computer. And then the heap is like our parents' place. We manage everything. That's why we need to use the keyword new to say, I want a new box with that's big enough to store an integer. I don't care about the label, but then I can also give you its a default value. So take this default value 0. And then after allocating that box, we need to delete that memory and take out what's inside the box and throw it away because that box needs to be empty so that for the next person who's going to use it, they'll find it empty, clean and ready for use. And then don't forget to cut the connection to that box because that box no longer has anything. I need to point to null pointer or to nothing. So that when I try to dereference, it'll be like, you're pointing to nothing. What box are you referring to? It's going to tell me that via this error called segmentation fault. So we understand that thoroughly, right? The stack and the heap. Stack it's managed for you. The heap it's managed by you. From allocation to deletion, everything's that is done by you. So let's talk about arrays, right? I don't think arrays is it's not too bad, right? So how do you declare an array? Remember a box, right? So far with the boxes that we work with, there's still one value. If you've noticed, I was inserting one value at a time. All of them, even the pointers, they were storing one address. All of them, they're storing one thing at a time. So how can I create the box that's big enough to store multiple values? You can create what we call an array. An array, there's certain limitations with an array. An array can only accept with an array you can only accept the same type. That's one thing about arrays. So with arrays, you can only accept the same type. You can't put strings and integers together. You can't mix that. For that, that's when you use something called a record structure. When you want to use different types to represent to store information for one thing or one entity. That's when things like record structures come in place. So arrays, this is the way you can declare them. You can start with the data type like this, right? And then a space, and then followed by the name of array, right? Basically, what does that array store? And then you put in the square brackets, and then you pass in the size, basically number of elements
Mm.
or number of values. How many values are in the array? In this case, if you only specified like one set of square brackets, this would mean it's a one-dimensional array. If you provided two, that's two-dimensional. Provided three, that's three-dimensional. So the number of square brackets is directly proportional to the dimensions. Same applies to pointers. If you have 2 pointers, that's a two-dimensional array. 3 pointers, three-dimensional array. 4 pointers, 4D, and so forth. So let's declare the array. Let's say an array of marks, right? Which is your
Mm-hmm.
practical marks. So remember the number of values or size, it means how many things do I have? I could say prac marks, right? Inside the brackets, square brackets, I should provide the number of practicals that I have. We have 10 pracs. So I'm going to put 10 there. And then to initialize or to assign, you just use the name of array with square brackets and then you provide the index or the position, and then is equals to some value. So that's pretty much the formula. So before I do that, let's explain what an array is. Like in terms of visually how an array looks. It's called what? Paint. So I'm using my touchpad to draw. You're gonna forgive me on that. My diagrams might look ugly. But then let me see. I don't see a box here. I don't see a box. I could have just dragged and dropped the box here. I don't see it. Is there? Nah, I don't see it. Or maybe I can put. Yeah, there's not there. I'm just going to draw a box. So remember, each drawer has a box, one box. So when you say you want to create an array, it's like you're dividing it into sections, that one box. That's simply what you're doing. You're still using one box. So that's a restriction with programming, right? To always use one box. So we're gonna have this box in that drawer, right? That one box. Okay, this is not bad since it's not a bad drawing since I'm using my touchpad. So there's the box, right? So what happens is that box, it gets divided. So whatever number you put in there. So let me make it smaller. So if I put 5 there, right, that means divide it into 5 portions, meaning that it's going to draw 5 lines, or it's going to have one to store one there, two, the second value goes there, three, third value goes there, four, five, right? The fourth value goes there, the fifth value goes there. And then since it's like this, right, it's going to also be like this. Remember, it's divided. It's still the same box, but then it's like dividing it into portions like this. And then each box is going to have a starting address, right? And then this, remember, it's in hexadecimal. So it's going to be like 0x, blah, 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 whatever that value is. And then it's going to move in that direction, right? But then it needs to know by how much to move in that direction to get the next value. So remember, each value is stored at that specific part, right? So this here would take in this, say, for example, the integer number 2, and then this position would take in an integer number 4. Okay, let me just say 5. Okay, this is really not bad for someone who's using a touchpad. 7. I'm just gonna put random values, right? I'm just choosing at random here. Let me undo that. Okay, so that would be 10. Let's just say 10, right? And then that part, this would be 3. And then remember, arrays are 0 index. You start counting from 0. So in this first portion here, where there's the 2, that will be position 0. So I'm just going to put that position 0, position 1, position 2, position 3, position 4. So if you try to access index 5, you want to get an error because it doesn't exist. But then when you create the array, you pass the actual number, how many there are. But then the way the computer counts starts from 0. Why does it do that? There's an actual reason for that. I'm trying to explain this. This is why I feel like a tablet would be perfect for things like this because it's hard to explain it like this when you have a laptop. Or at least if my laptop was like touch screen, that would be nice. So it has a starting address. Basically, so what happens is when you create the array, the main important thing is the size, the data type. The data type will help determine the size, basically how many steps or something like that it should move by. So this would be an int is equivalent to 4 bytes. If you remember, when you're talking about bits and bytes, 1 byte is equivalent to 8 bits. So how many bits would this be? This would be 4 times 8, which is 32 bits, right? So it knows, I'm just gonna use it in terms of bytes so that you can understand. So bytes, just think of it as like taking 4 steps before I get to the next address. So it's going to divide every section, each each box, right? The way it works, right? It's going to have each box, and each box is gonna have its own start address. It will not it will not take into account the way it ends because it has the size. It knows by how many steps it must move. So if I'm moving by 4 steps, right, or 4 bytes, that means based on that logic, it follows that I have to start from zero, index zero, position zero, because the formula to find the address the starting address of the next number in the array is that you add 4 bytes, right? You just add. Remember, I'm saying 4 bytes because it's a array of integers, and each integer is 4 bytes. So it's gonna start at position at zero, right? So let's just assume it's zero, and then it adds 4 bytes. Then it knows, okay, that's where the next integer is, right? Or that's where the next integer starts from. And then it adds 4 bytes more. That means the next integer will start at 8 bytes. And then it adds 4 bytes more. That means the next integer will start at 12 bytes. So that's pretty much how it's going to work. But then the actual formula to find the index, if I still remember, what's the actual formula? Yeah, is the size, is the number of bytes, right? The number of bytes, if I'm not mistaken, the number of bytes, is it the number of bytes for 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 all of them, or no, it's number of bytes for each value, right? And then I think it's plus that indexed. Oh no, it's all in. Okay, yeah, I see. I still remember now. It's the starting address, right? The start address plus, right? Plus some calculation, which is the index times the number of bytes. So by times number of bytes, what does that mean? It's 4 bytes since this is an array of integers. Each integer is equivalent to 4 bytes. By starting address, when you create a practical what is an array called pragmax like this, pragmax, it what happens is the array name itself, it actually stores an address. So it actually behaves as a pointer. You'll be shocked, but then actually behaves as a pointer. So if I see out pragmax without an index, should give me a hexadecimal value, like a starting address. Basically, when you create that array as expected, there's that hexadecimal value. Like I said, you see, I didn't lie. Thankfully, it starts at zero. So we're gonna ignore all the other values, right? We're gonna look at the far right to show you that it increases in terms of 4 bytes or by 4. At least it starts at zero. So as you can see, it uses the starting address, right, of basically what happens is when you create an array, the name of that array is going to store the address of the first value in your array. Basically, this zero. So my preg will store here. It's going to be OX something. Obviously, it start at zero in order for the formula to work. Why do I say so? In order for this formula to work. So let's try to calculate. So starting address plus what's the index? What's the position? Position zero, right? That means, remember, any number times zero is just zero. So 0 times 4 will just be 0. That means I just get back the starting address, which is the first number. So that's why. So it's like to get the first value, right? First value, we always use remember, we're gonna use that formula. What's the starting address? Remember what I said, the name of the array stores the address of the first element or first number in your array. So I'm just gonna use the name of the name of the array, and then I say plus index is position 0 times 4. What is any number times 0? It's just 0. So therefore, the first value is just this. And then to get the next element, right? There's a second, right? Remember, we start counting from 0 simply because of this formula. If I didn't count from 0, right? Let me show you what would be the problem. This would change to 1 times 4. which means I'm gonna move 4 bytes, which means that this is zero, this value at index 0 will be ignored totally. I'm gonna start outputting this value 1. That's why arrays need to start at 0 because it uses pointer arithmetic. This is called pointer arithmetic. Since this variable name, any array, it works with pointers. It works with addresses basically. It's a pointer, even though it looks like that. It's a pointer. That's why you saw an address when I displayed this. So since this formula is a bit advanced, right? The way we sort of like move to the next value, we just increment by 1. So let me show you how I can find the next address, right? Remember, it's 4 bytes each. So the next address, I'll just say plus plus. The next address should be, you should end with a 4 at the end. If I'm increasing in terms of 4, because the first that it has that 0. Remember, the far right value was 0. I'm expecting the next far right value to be, okay, it doesn't want. L value cannot increment. Yeah, it always does this. So let me try to pre-increment. Let me do that. Let's see if that will work. That's the thing about C++. It's complain. Sometimes it works, sometimes doesn't. So it doesn't want to behave, which is fine. I'll come up with, let me see, I'll come up with the way on how to represent that. But then you'll see that it's going to be, let me come up with the way. Let me show you the way. So I could do this, right? Let me initialize all the values, right? So let me rewrite my notes here so that when you look at this, you don't get confused. This would be 1 times 4. So here I'm going to initialize my array. So index 0, we said is going to be 2, and then I'm just going to copy and paste for time. 5, 7, copy. Then this will be 5, 7. This is now index 2, index 1, and then 10, 3. Then this will be 10, this will be 3. So as you can see, it starts at 0 and you stop at the number before the number of elements, right? I have 5 elements. As you can see, I stopped at 4, which is the number before 5. So most of the time, that's the formula. It's just going to be the maximum number of elements you have minus 1. That'll be the last position or the value, the last index. So to output, I'm just going to say output that position 0, but I want its address. I want you to see the differences in the addresses. They increment by 4 since each value in the array is an integer, meaning that it's 4 bytes but it's different in terms of 4 bytes. So 1, 2, 3, 4. So this should end with a 0 on the far right. This should end with a 4 on the far right. It should end with an 8 on the far right, because remember it's incrementing in terms of 4 bytes. It should end with a 12, then it should end with 16, if my math is correct. I don't know about the 16. Remember, it's hexadecimal. It's going to use the letters A, B, C. Yeah. So as you can see, 0, 4, 8. 8 plus 4 is 12. If you look at the hexadecimal letters, you'll find out that C is actually 12. There's C, right? Remember what I said, this is 10, 11, 12. So C is indeed correct. And then I add 4 more, which is going to be 16. Yeah, there's a B now, right? If you pay attention, there's now a B, 0, right? So it's the main important part that we need to see is this part, right? 0 to 4 to 8. So when it does that, it only, remember this address it's only storing the starting. So this would be 0, where I pointed there, and then this would be 4 ends in a 4, right? Because that's the next 4 bytes. And then this is the starting for where the 2 is stored. It's gonna end with an 8. And then this is the other one. It's gonna end with a C. And then this is the other one. It's gonna end with 0, right? Or B0. Let me just write in full B0. So as you can see, each of these, it's the same box, but then it uses that address, sort of like it's called pointer arithmetic, whereby it's using an address to find where the next value is. And it knows that each value is the difference, right? Do you know what that bytes I was talking about means? It means the distance between them. So this from there to there is 4 bytes. Same here, from there to there is 4 bytes. Same thing. It was able to count from 0 to 4, 4 to 8, 8 to C, which is 12, and then 12 to 16. So that's pretty much how an array works under the hood. To show you that is indeed true, what is this? Show you To show you that this is true, I could use, what is this, pointer. I could dereference, right? So let me show you. I could say cout. I'll just output using pointers, right? Using actual pointers. I could output the addresses for I could get the value, right? So I can say point to pragmax. Remember what I said, the name of the array, it points to the address of the first element in the array. So if I dereference this, I should get 2. There's the 2. Like I said, arrays are pointers. It's working with addresses. So I could also just do this to find the next element. Hopefully it works now. Hopefully. Let's see. I could dereference. Before dereferencing, I need to move 4 bytes. So to move 4 bytes, it's basically the same as like adding one integer, because any integer, right? Any integer. Because at the end of the day, that integer its size in terms of bytes, it's going to be 4 bytes. So I could just say pre-increment like this, pragmax. So now I've moved 4 bytes to the next element. So my output should be 5. Hopefully this works. It did work in my previous tutorial. Let's see. Okay, does it today it doesn't want to work. So let me try just adding 1 there. What about that? Does it like that? Okay, it didn't complain. Yeah, okay, yeah. So it didn't complain when I did that. So you see 5, and then now I can I added 1 to this, right? But then I didn't actually change it. So that's a problem. So you could do this, right? You could, because remember when you use it like this in this statement, you haven't changed the value of pragmax, the address. I haven't changed it. What I can do to change it permanently, I can just say pragmax like this, plus or equals 1. I can do that, right? Before outputting, and then I just do this, which is the same thing that I did. But then I incremented by 1, which is going to convert it to 4 bytes, because the pragmax stores addresses. So it's going to use 4 bytes. Hopefully it doesn't crash. This thing is just peak. It's just peak. That's why they don't teach it in this advanced manner. But then if I was the lecturer, I would have a practical, but you use the array and initialize the values using uh pointers. You create the array normally, but then you have to do it this way, not the way of for loops and things like that. So I could dereference and then pragmax. And then now I'm not sure if this would work, but let me try to add 2. I think it should work. By 2, right? I'm trying to say 2 integers. I hope that's, yeah, it works. So by 2 integers, remember, the way it's weird, right? It's a weird thing. If if you use 1, it's going to assume that's one integer. Remember, you're incrementing it by 1, meaning you're incrementing it by 4 bytes. Here you're incrementing it by 4 bytes, which is 2 times 4, which is 16 bytes. Uh, uh, yeah, no, 4 times 2 is 8. Maths, which is going to increase by 8 bytes. By 8 bytes, it means that now I'm getting to 7. And if you look at something, right, I'm actually using the indexes. If you notice, I'm using the indexes, but I'm using pointer arithmetic to get the values. So As you can see, I didn't lie about that formula. The formula that I'm using here is this one, right? I don't need to say times the size in bytes. I don't necessarily have to say that. I could just say plus the index. It will calculate. So 3, index 4, index 5. Right? No, there's no index 5. Remember, arrays stop at the index before the size of the array. So now I should see all the values. No, this is not, I didn't want to, okay. So now you see all the values are there. And did I even use a loop? Nope. Because I understood pointers. I understood arrays that they under the hood they are pointers. I can dereference. And then I can just say that the starting address plus how many bytes I want to move, which is basically like the index. Just say the index. What is the index for it? If you wanted to actually use the formula, let's try to use it. The full formula, right? Which is start address, meaning the name of the array. Remember, the name of the array stores the starting address of the array or the address of the first element. And then index is the position that you want you want to index, which index in the array, and then times the number of bytes. Let's try to do that. To get the number of bytes for that variable, right? You can use the size of function. It returns the size of bytes for that variable. So if I want to get the size of, let me see. Let me choose a random value, right? Let me say pragmax at index 0. I want to get that size, the size of that integer. If I say C out here, it'll show you in terms of bytes. So I'm just gonna append that bytes string so that you know that it's in terms of bytes. So I'm expecting 4 as my output. I know it's weird. It's weird, right? It's not too weird. I'm just getting an element, a value in my array. I pass it to the size of function, which is going to return the size of this in bytes. It doesn't come with the string bytes, so I have to append that string at the end so that it's easy for you to understand the output. So if I say this, as you can see, it's 4 bytes, which can be noted here in terms of the addresses. They're increasing by 4. If I had used an integer, a short or something different, the bytes would be different. So let me show you. Let me just make a subtle change. Let me say short. The bytes are going to be now 2. It's going to be 2 bytes. I just changed one thing. You see, 2. And you can also see it here. From 6, it went to 8. From 8, 8 plus 2 is 10. Remember, A represents 10. C is 12. And then 14. This will be 14 from the mistake. Yeah, 14, which is E. And then F is 15 here. So this is right. So you see, it's 2 bytes because I used a different data type. Because that data type, it means it's going to tell the computer what's the number of bytes for each element in the array. If it's int, it's 4 bytes. If it's short, it's 2 bytes. If it's a long, it's 8 bytes. So you don't need to worry about that too much. So as you can see, this function helps us to get the bytes. So like I said, the formula is the index you're trying to get times the size in bytes. So times size of, I know it looks weird. That's why I just say +1. Now it's gonna look very cryptic, very weird. But then remember, we're still just applying this formula, right? We're just applying that formula. Size of prex, right? Preg max. And remember all the values in the array, they have the same bytes. So I can choose any. I can index into my array and choose any. You choose index 0, the first element, because I just want to get the bytes. Remember, when you use this function, right? The main purpose for using this function, size of, is so that if I go there and I change my code, right? I change this array to now accept shorts. I don't need to change anything else in my code because I use the size of function, which gets the size of any variable. It gets its byte size of that variable in terms of bytes. So this will be the full formula, right? But then C++, for some weird reason, it doesn't want this. So that's why you just need to pass the index, say +1 or +2, that index that are trying to get the value for. Let me see if it did crash. So at index 2, it's 7. Okay, it didn't crash. That's the thing. Sometimes it works, sometimes it doesn't. Okay, now it's working. So yeah, you could do that. Yeah, so but then I wouldn't advise doing that. Just use the index. Just say one, the index one. That's one I want to get, and then dereference because I'm doing address arithmetic here. I just want to move to that address, and then I dereference, so I go into that address to get the value. So it's like I want to move 4 bytes to get the starting address, and then if I get the starting address, this one, let's say this one, then I know, okay, if I dereference, I'll get one as my, I'll get not one, I'll get 5 as my output. And then if I do the same thing, I add, remember you're always looking at it with respect to the starting address. If you look at this third box, or this third sort of like third column, right? How many columns did I have to skip to get to there? Two, right? It's 2 columns. Hence the 2 there. You look at the next one, the 10. How many columns did I have to skip? 1, 2, 3. I had to skip 3. So therefore I said plus 3. Just to skip those 3. And then the last one I must skip 4. You don't believe me? Look at the last one. I skipped 1, 2, 3, 4. So that's why I say plus 4. That's another way of viewing it. So I hope arrays make sense. Like I said, computer C++ is very complex. It's easy to pass, right? To understand, but then it's complex. It's quite a lot to cover. So
Yeah,
that's pretty much arrays. I don't think I should, with the amount of information I just gave you right now, I think I should just end it here. Else your brains will be bombarded with too much information.
yeah,
Yeah, I think this should suffice for now. So I'll just change this back to an int. So that's pretty much pointers. I'll also send you the code and everything. So
yeah,
it's pretty much the pointers, arrays, and then okay, let me just cover it, right? I just want us to get to be over with arrays. You can also detect if you want to. You can use the heap like you've been using the whole time. You can say int marks, right? And then make it a pointer because I want to use the heap. Remember, the heap returns an address to that box. Remember, the box is still the same. Since I'm using an array, it's going to be a box that's divided into these sections. So it's still the same thing, just that I'm using a different storage, sort of like a storage device or storage place. Let's say, let me just give you a simple analogy, right? It's like this first one, right? I was using maybe a USB. And then here with pointers, since I'm gonna use the heap, I'm gonna use a different way of storing the things or a different way or per place, right? Let's say here I'm using now a hard drive. At the top I was using a USB, now using a hard drive. Does it change the fact that I'm storing the things? Nope.
no,
Still the same thing. So I'm just gonna allocate it on the heap, new int, but then I do not want one integer. I want multiple integers. So I'm going to say same thing, 5. And then I'm going to output before I do anything, right? I'm just going to output using the heap memory so that you can distinguish which part did I use the heap memory. I'm going to initialize it the same values, 2, 5, 7, 10, 3. So to initialize, it's weird, right? I know it's weird. You actually you do it the same way. You see this exact same way, I do it that exact same way. So I'm gonna do that. Or you could let me show you the advanced way. You see this, remember that this is how I can remember pointers, how it works to change the value inside the box. You point to the address. So I'm going to use my knowledge right now of pointers. I want to say point to max. Remember the name of the array, it always points to the first element, which is this position here, the starting point, right? But basically it means that it points to index 0, the first element in the array. So I'm gonna point that and set that to 2 because this one was set to 2. And then the next, I'm gonna point, but then before I point, I need to move my address by one, right? Basically by 4 bytes. So plus one is equals to 5, if I'm not mistaken. Yeah, 5, 7, 10, 3. And then the next one I move by 2, plus 2 is equals to 7. And then max plus 3, I move I move by 3. And then max plus 4, the last one. I initialize it to 3. And I can just do the same thing here. I can just output them the exact same way. Remember, this is just me showing you how to use pointers or how to use arrays in terms of the way they are under the hood, which is just pointers. You could just index, say at see out at index 0, see out at index 1, see out at index 2. You could do that. That's perfectly fine. Hopefully this doesn't crash. Let's see. Okay, perfect. As you can see, perfectly executed, no errors. You see, don't you see that is the exact same output? 2,
Yeah.
3, 2, 5, 7, 10, 3, 2, 5, 7, 10, 3. Exact same thing because pointer arrays under the hood, they're pointers, or it's an array. It makes use of addresses. So you could technically, if you want to be like, in a showcase, like, yeah, I'm him. I'm built different. You just do this, they'll be like, yeah, this person really knows what they're doing. And then your code will be unique. Not even ChatGPT will generate this code. I'm telling you, this is not the code that ChatGPT generates. This will never be generated by ChatGPT. It will generate the normal one, which is like doing this and saying max square brackets at index 1, like this. But then you understand this is pointer arithmetic. The array is a pointer under the hood. So you're just gonna do that. Move the address by 1, basically by 1. Remember, this will just be under the hood, if just 1 times 4 bytes. This will be times 4, the size of the number of bytes. So you can omit the 4, right? That's C++. But in languages like assembly, you have to, which is ComSci 3B, you have to multiply by 4. If you don't multiply by 4 or you don't use 4, then it's not gonna understand what were your intentions. So I hope that makes sense. So I'm just gonna end it here. There's quite a lot that we had to cover. So that's pretty much an array. Just remember, it's still one box, but then it's like divided. It's like this, right? Let me make an example. Let me say cats in one box. Let me see if that I can see. Well, it's not really what I'm looking for, but then now you kind of get the idea. Yeah, I don't see that. There was an example in the slides for informatics. You used a cat, I remember, back in the days when I was doing it. Yeah, but then it's like you have multiple things within one box. It's like they just divide it they put that one box into sections. But then you're still using those normal ways, whether you're using the stack or the heap, still doing the same thing. So that'll be it for today's sessions. Do you guys have any questions?
Mm. Yeah, but I think I'll text it to you.
Okay, no problem.
Yeah.
Coquette, so do you have any questions? Is it still there I guess is it's fine. You just text me if you have any questions.
Yeah.
Yeah, so thanks for joining the session. See you in the
Thank you.
next session.
Sure.
Sure.